Welcome to Unit 3. We're going to go ahead and get started with 3.02, working with polynomials. Our goals for today are to be able to determine whether an expression is a polynomial or not. That will be on your quiz. Classifying polynomials, there's two different ways we can classify them, and then add and subtract them. So before we get into it in detail, let's talk about just the fundamentals of polynomials. Poly means many. Nomials means terms. So it just means an expression with many terms. How many terms would you say this has? Hopefully you're thinking 1. So terms are separated by plus and minus signs. Write that down. Terms are separated by plus and minus signs. So taking that into account, now, how many terms do you see? 2. There is a plus sign there, separating this term from this term. So notice there can be numbers, variables, exponents, but as long as everything's touching, like it is here and here, those are individual terms. Okay? So let's take that into account as we look at this next screen. There's a more detailed definition of a monomial. It's basically what I just said, but if you like that definition, read it, write it down, add it to your notes. Okay, a monomial is a type of polynomial, and you might think that's a little strange. Why is one term many terms? That doesn't make sense. Well, you're right, but it's just the way it is. A monomial is a type of polynomial, and that includes one term. Mono meaning one. So if you see a regular number like -25 with no variables, no exponents, this is a monomial. Okay? So any constant, 5, 100, -25, -7, these are all constants. They are all monomials, but something like this is not. And here's why. Okay? Because this could be written like this, and -2 is not a whole number. Okay, so whole numbers, 1, 2, 3, 4, and so on. Okay, so if your variable is negative, or you see the variable in the denominator, the exponent, if your exponent's negative, like it is here, or you see it in the denominator, like you do there, this is not a monomial. Okay? That exponent must be a whole number. So a little recap, is this a monomial? It is. There's no plus or minus signs separating anything. Even though there's different variables, different exponents, doesn't matter. Now, what about when it comes to finding the degree of a monomial? A single term. Well, to do that, you need to take all the exponents of the variables, exponents of specifically the variables, and add them together, and that gives you the degree. So pause this and give it a try. Now let's see what the answers are. 6d can be written as 6d to the first. And it's all about the power of the variable. So this is a 1, aka a first degree polynomial. Okay. What about the next one? You said 10, you're correct. It doesn't matter, again, if the variables are different. You just take all of the exponents and add them together. Now the last one, what would you say the degree is of that monomial? Well, this is a constant, okay? It's not about what is the power of the number. We said up here it's about the power of the variable. Well, there is no variable, so that's a 0. 0 degree monomial. Now, you just found the degree of a monomial. Finding the degree of a polynomial is very, very similar, but there's just more of it. Okay, so think about this as I read it. The degree of a polynomial is equal to the degree of the monomial with the highest degree. So try to solve these. Think about the way we just found the degrees. Again, there's just more of it. So here's a term, right? Technically, do you know what this is called altogether, this whole polynomial? It's called a trinomial because there are 3 terms. We'll look at more into those definitions later, but you're taking each term and finding the degree. F to the 2, F to the 1, 5, no variable, or you could think of this as 5F to the 0 if you'd like, but that's 0. So because the highest degree of an individual term is 2, the degree of this polynomial is 2. What about these? Well, we have R to the 4th plus S to the 5th, so that's the degree of 9. This is 3R cubed, S to the 8th, add those together, so we get 11. And then we have S to the 10th, R to the 1st. So clearly, the biggest number between 9, 11, 10, and 1 is 11. So that degree is 11. Not too bad, right? But you do need to know what to look for. So make sure you take good notes, take screenshots, and study. Now let's talk just for a moment a little more about monomials. We talked about how a plus or a minus sign separates monomials or terms. Okay. And do you know what we call a polynomial with 2 terms? Well, that's called a binomial. So mono is 1, binomial is 2. Okay. Now, let's work on organizing these polynomials in standard form and getting a little familiar with the vocab involved. So standard form, guys, you see it through math all the time. We saw it in Unit 1. We saw it in Unit 2 with different things like imaginary numbers, linear equations, right? But now we're looking at standard forms of polynomials, okay? And here's how we do it. You need to first make sure there are no like terms. What does that mean? Well, it means if you had like terms, you combine them. But you don't have like terms anymore. And you want to write this by decreasing degree. So getting smaller. So look at the highest degree. Hopefully you're looking at -3y squared. Or no, y cubed. I had to double check. Y cubed. Okay, got that one. Maybe underline as you go so you don't miss any. -3y squared plus 21y plus 4. So notice, if this could be written as y to the first. If you really wanted, you could write this as y to the 0. Don't have to, but you see y cubed squared to the first to the 0, decreasing order. And don't forget, it's about the power of the variable, right? Okay. So this also really helps you when you're asked to find the degree of the polynomial because you put the degree first. So you could just say, okay, 3rd degree polynomial. And some vocab you're going to hear me use a lot throughout this unit and this school year is leading term and leading coefficient. Do you know what the leading term and coefficient are right now? Hopefully you see that the leading term is this y cubed. And if you don't see a coefficient, it's always 1. So the leading coefficient is 1. Okay, so now you know how to write a polynomial in standard form. You also know how to categorize it based off the degree, and you know a little vocab there. We've already begun to classify a bit, but we're going to do this in more detail right now. Okay, there's 2 ways I mentioned earlier, by the number of terms and by its degree. So let's start by looking at the number of terms. We've already looked at these. 1 term means monomial, 2 terms binomial, 3 terms trinomial, and if there's 4 more terms, we're just going to call it a polynomial. There are more terms, but why get more and more complicated? Let's just leave it at that. Now, we did say 4 more terms we're going to call it polynomial, but what about the rest of these? Are these polynomials or not? Like this one, and this one. Well, they are, right? We said earlier, even a monomial is a type of polynomial. Okay, but sometimes we want to get a little more specific when we categorize them. Okay, the other way to classify is by degree. A constant like 10 or 30 or -5 doesn't have a variable, so the degree of that is 0. If it has a degree of 1, it's linear, right? Just like a linear equation. 3x to the first minus 2. What else do we have? We have quadratic, and guys, you are going to see this a lot. This will be a big focus. It means it's degree 2. So here you see x squared as the leading term. Cubic means the highest power is 3. And the last 2 here, you won't see as often, but you will need to be familiar with them. Degree of 4 is quartic. Degree of 5 is quintic. Okay. And there are no special names for polynomials with degrees greater than 5, like we see here. Okay, let's go ahead and practice writing these polynomials in standard form and then classifying them by degree and number of terms. Hopefully you got a chance to practice. We want decreasing powers. So 3, 2, 1. Or 0, actually. And that's interesting, right? Notice this could be written as 7x to the 0. You don't need to write it like that, but just know that can be written as such. But notice we can skip numbers, right? 3, 2, 0. You don't need a 1 there. You don't always need that. Okay. Now, classify this by degree. This is a 3rd degree polynomial. Right? What do we call that? Cubic, right? This is cubic. And what about number of terms? Well, it's cubic because there's a 3 there, but there just so happens to also be 3 terms. We call that a trinomial. So this is a cubic trinomial written in standard form. Okay, the highest power I see is 4. Then is there a 3? Yes, there is. 2, 1. I don't see any like terms, so that's done. There is the highest power of 4. So if we look at our table above, that's going to be quartic, like a quarter, 4 quarters. And how many terms? 1, 2, 3, 4, 5. Well, if it's 4 more, we'll just call it a polynomial. Doing good? All right, stick with us. We just have a little bit more to go. We want to practice adding and subtracting these polynomials. You've done work like this before. So see if you can do it. Follow the rules of PEMDAS. Okay? PEMDAS, PEMDAS, PEMDAS. So looking for like terms inside parentheses to combine. Nothing to combine, no like terms here. So we want to distribute that positive what? Positive nothing? Positive 1, right? This term will not multiply with anything, so we can release it from its parentheses. Minus 3m squared. Here we go. There we go. Now look for like terms. 9m, negative 5m. Okay. 4m. Any constants other than negative 12? 15 plus 3. And then we have minus 3m squared, which is all fine and dandy, but let's put it in standard form. M squared, m to the first, and then m to the 0. The next one, there are 3 terms times 3 terms. Nothing wrong with that. Just a little more work. So distribute that negative 1 to everything. Again, this will not multiply with anything. So we get that again without parentheses. Same signs positive. And this time I'm going to start with the highest power to just save myself a step. So I have like terms of negative 7y to the 4th, negative 3y to the 4th, so negative 11y to the 4th. What's next? Y to the 3rd. This is all by itself, so we'll write it there. So we have y squared, no y squareds. Y to the 1st, yes, 6 plus 5. 11, and then 1 constant at the end. And actually, the first term should have been negative 10. Negative 7 minus 3. Always pays to double check. There we go. So we've accomplished all of the goals we wanted to learn from our goals we mentioned in the beginning. So now it's time to practice and study so you can do well on the quiz.